All right. Hi, everybody. Welcome back to our monthly Future in Space Hangout. I'm Tony Darnell from deepastronomy.space, and today we're going to be talking about the NASA's efforts to get the Gateway habitat underway and the testing that's happening with that. And I want to let you guys know that these Hangouts are sponsored and endorsed by the American Astronautical Society, where every month we try to bring their membership to you so that you can get a sense of what the membership of the Astronautical Society is all about, some of the really cool and exciting things they're working on, because let's face it, astronautical stuff is huge right now, and we've got a lot of cool things to talk about. So these are very timely, and I want to thank the American Astronautical Society for bringing them to you. If you would like to learn more about that organization, please click on the link in the description box. They are full of great stuff if you become a member, and lots of great things that you can learn about there. So I wanted to bring your attention to them and thank them for their sponsorship. So today, as I mentioned, we're going to be talking about NASA's Lunar Gateway habitat. Now, as many of you already know, NASA has made plans to put boots back on the moon using from the project Artemis project to get us back to the moon by 2024. And there are many different parts to this mission, as you could well imagine. One of them is NASA's Lunar Gateway, and a part of that is the habitat. Where are we going to put people? So with that, we're going to be talking about that with our guests today, and I'll introduce them here in just a second. But I want to let you know that we are streaming this live on YouTube, which hopefully I see many of you are already watching. We're also on Twitch, Twitter, and Facebook, all under the Deep Astronomy headline. So please check it out and leave questions and comments for our guests. I'm monitoring all of them, and I will read them out as we go along. So let me go ahead and bring up my panel of people here. It's hard to know which is left or right, because sometimes things get turned around. But in my upper left is former astronaut Rick Mastracchio. He is like I said, he was a former Shuttle astronaut. He's also the Senior Operations Program Manager at Northrop Grumman. He works also on the Cygnus spacecraft, and he is right now joining us in Virginia, where they are getting ready for a launch this Saturday to resupply the International Space Station with materials and supplies. So welcome, Rick. It's good to have you on our Hangout. Right below me in the little panel here is Stephen Robinson. He's a professor at UC Davis. He's also the director of UC Davis Center for Spaceflight Research. He works on habitats, folks. So if you got questions on habitats, he's your guy to ask and to get some decent from the source answers from. And finally, last and certainly not least, is John Olenson. He's the Gateway Production Manager at NASA's Johnson Space Flight Center. So welcome, everybody. John, I would like to start with you.
Thank you for having us.
Yeah, yes, this is great. I'm really excited. I'm a little bit jazzed here, not the least of which because I had a Red Bull. Sorry, I have to, full disclosure. But John, I'd like to start with you since you're at NASA and you are coordinating these efforts. As I understand it, NASA is currently looking at proposals or designs for the habitat module. Is that correct?
Yes, that's correct.
Or maybe give us a little background on what that's all about.
Absolutely. So as you look to get to, as you were saying, get back to the moon, get the first woman and the next man on the moon's surface in 2024, we're looking to put a gateway outpost in place in orbit around the moon to enable not only that first mission, but a sustainable platform to continue our exploration of the moon going forward. In order to do that, we need to create a capability to house crew members, astronauts, on that outpost. And so we're looking at different ways to do that. So you need some type of habitat capability, as you were saying, in order to put that in place. We are working right now to define all of the requirements and the initial design concepts for the first habitation module that we put in place. It's called the Habitation and Logistics Outpost, the HALO module. And that work has just begun in the last few months and is going very well. We're working with Rick and the Northrop Grumman team to put all of that together. That is our first step, like I said, and there will be additional capabilities that will need to be added after the 2024 mission. But we need to have that capability so that we can get crew members to launch in the Orion capsule, being launched via the SLS rocket, have them head out to the gateway and use that as your transition vehicle to get into a lander and head on down to the lunar surface.
Okay, so just so I'm clear, you guys are laying the groundwork now, and before this part of the mission is going to be scheduled before we put boots on the ground with Artemis. Is that correct, or is it?
Yeah, no, you're absolutely correct.
Okay.
We will actually have this habitat, this first module, in orbit around the moon in the late 2023, early 2024 timeframe.
Okay, and I'm going to go ahead and put this image up. You guys can't see what I'm transmitting, but I'll just tell you, Rick, the artist's conception of what Northrop Grumman is working on, and I got this from the NASA's website that I showed you earlier. And while I'm showing this, I wonder if maybe you could talk a little bit about Northrop Grumman's role here.
Sure. A few months back, NASA asked Northrop Grumman Innovation Systems to develop and build the HALO module, as John just said, and I could see your graphic. So the team, the Northrop Grumman team, of course, with the NASA folks, are in the process right now of just getting that kicked off. And like John said, I think the gateway, and the term gateway and the term outpost are very good descriptions in my mind, and that it's much different than the International Space Station, which is a long-term habitat, whereas the gateway and the outpost, at least at first, are going to be used for the astronauts to pass through and spend shorter periods of time until we fully develop that gateway.
Now, in this image that I'm looking at, the graphic, is that on the right side of it? Is that the Orion capsule?
On the right side is the Orion capsule, and the HALO module will be the probably the second from the left module. It's that node-looking thing.
And it's on the axis that they're
on the axis,
the same axis as the Orion capsule.
So the HALO module will be an early habitat for the crew, and it'll also be what we call a node where 3 other vehicles can dock to the early gateway.
How big will this thing be? How many people will it hold?
Well, it's let's see. It's the size is 15 meters long, John?
That's about correct. It's about 37 cubic meters of living space.
37 cubic.
Well, not very big, but big enough to hold the 4 crew members of who will be flying up on Orion for a short period of time. Plenty of room.
Okay. And I'm going to go ahead and ask Hans Milling's question because it's a good one. But since you're designing it now, he's asking, are you going to use inflatable modules like the one being tested on ISS? This is, I guess, for you, Rick. Or are you looking at a hard structure that's going to be launched as part of a rocket and built in space?
Oh, no. This is a hard structure. The structure is based on our Cygnus module that we're flying today. We've been flying for the past 4 or 5 years, and we're about to launch another one. So the module itself is based on the Cygnus structure.
Okay, now, so let's talk a little bit about the Cygnus rocket right now. You're in the process of loading one up right now. And so you're basing your design, Northrop Grumman's design, on using this particular rocket. Tell us a little bit about it, what it can do, and how long has it been in service? Just some general info on on Cygnus.
Sure. The Antares rocket launches the Cygnus spacecraft into orbit. The Cygnus spacecraft consists of a service module, which propels the vehicle to the International Space Station. The pressurized control module, the PCM, that's the canister-looking part. That's the Cygnus spacecraft, part of the Cygnus spacecraft. That's where we load the cargo into, and that's how we deliver it to the International Space Station. So we're taking that module, that pressurized module, we're stretching it, make it a little bit bigger to give the crew members more volume. We're adding some radial ports to it, and of course, the service module on the back end has to have some additional capability to go from low Earth orbit to HALO orbit or cislunar space. So we're enhancing that vehicle overall and then take that to cislunar space, where we'll dock with the rest or the early portions of the gateway, and then that will then begin to allow the Orion spacecraft and other modules to come to that gateway and dock. And there the crew members can transfer from the Orion spacecraft to the lunar lander, the human landing system, go down to the moon, perform their mission, come back up to the gateway, take their samples and their science over back to the Orion spacecraft, and then fly home.
Wow. I want to get to some of that. Well, you just said a lot of really cool stuff there, yeah. but I want to just take a quick step back and John ask you about how do we get there? Let's just go from right now. Nothing is there in cislunar space, and you're looking at designs for the module. This will be one of the first things to go. Is that right?
That's correct. And the first element is actually called the power and propulsion element, or PPE, and it will launch a year before our habitation module launches, our HALO module. It's going up. It'll actually be the source of all the control that you need, as well as the power generation. So it'll have large solar arrays, and it'll have the engines needed to maintain the orbit for the station.
All right.
Or the outpost.
And what is the schedule for that to happen? 2024 is coming up. I mean, it's quick. So
that's correct. And so that is in development already. That was awarded to Maxar Technologies several months ago, and so that work is ongoing. We expect that vehicle to launch in late 2022, so about a year before we launch the HALO module.
Okay, so 2022, we're going to have sometime up there. We're going to have this power. What'd you call it? The power and propulsion module? Is that right?
Power and propulsion element.
Elements.
Yes.
Okay, and then followed by the design for the whichever one you pick for the habitat.
The HALO module.
How is that going to go? I mean, where are we in that process? Northrop Grumman has just talked about. Rick has talked about their efforts. You're looking at 4 other designs. Am I right?
So that's correct. I was going to say that. So the question you got about inflatables.
Yeah.
We're working with Northrop specifically for this HALO module that we're putting in place for the 2024 mission. We need to get that work ongoing. Like you said, 2024 comes quickly. And so there's a lot of work to do to make sure that we get the components we need up in cislunar space so we can execute that mission. But there is work ongoing with multiple different vendors looking at habitation capabilities, overall habitat designs, as well as component capabilities associated with them. And so those vendors have been working with those activities for several years now, including Northrop Grumman, and that work continues with those vendors, including inflatable habitats.
Okay, Stephen, I want to get you in on this real quick because I'm particularly interested in hearing your thoughts on this question that I have. I am scared crazy about this idea of sending and spending a long-term period of time outside of the cradle of Earth's magnetosphere. And we don't have a lot of experience outside of it. We've got the Apollo missions, of course, that spent a few days on the surface and came back. Their total exposure was very short relative to how long astronauts are staying in the ISS. As someone who works on habitats in space, what are the biggest challenges that you face in designing it? And do you think human beings can live out there for any length of time beyond just a couple days?
Well, I think we all worry about radiation. There's a lot of people everywhere in the space community and even spaceflight community worried and working on radiation protection, radiation scatter, and understanding physiological response to deep space radiation. So that's probably, from the human point of view, one of the biggest issues. Beyond that, really, it comes down to, like it always does, the safety and reliability of the vehicle and its software. And so, these folks and the army of people that they represent, that you've seen between Rick and John, working on Gateway, this is front and center of people's considerations. What we're doing from the more scientific academic point of view is thinking about how does future software help a vehicle stay alive while the people aren't there and keep the people alive when they are there. And that means being able to assess, respond, diagnose, and then repair or replace aspects of the vehicle while you're in place. So you probably have to build something in place. If you're going to build anything in place, you have to design it to be built on board. You have to have learning software that learns with the humans and possibly teaches the humans as well as learns from them. You have to have very advanced robotic systems that are different for the inside and the outside. And you have to have actually a different class of astronauts who understand how to team with automation and robotics. Big pile of stuff.
A new class of astronauts. What does that mean? It means a different training program than what astronauts are used to going through. Is that what you mean by that?
I don't know what I mean by that yet. That's part of the reason. I think part of what we need is we need astronauts who grew up on a farm. Our emergency room doctors are incredible at coding.
Was that
That's
you?
all.
Was that you, Rick? Did you grow up on
That's
a farm?
Rick. Yeah, just like Rick.
Did you grow up on a
Oh,
farm?
but I am willing to learn.
I am willing to learn. So I think what you're talking about is the mindset that, hey, I'm out here in the South 40 and this pump just broke. I'm going to have to fix this thing right with the stuff I've got on me. And
Well, that's always been the mindset, but really, I think future astronauts are going to have a deeper background in software engineering.
well, I could say the same thing about astronomers, but that's a different hangout. Yeah. So, okay. Well, let me get to, I want to ask Raj Luthra's question. He's got a couple good ones here. I think we know part of this answer, but I'll ask it first. What launch vehicle will be used to launch the Lunar Gateway components? Now, in the case of Northrop's, you're going to use the Cygnus, right? But is that across the board what everybody's going to use?
No. The Antares rocket is not going to be used for cislunar space. So for cislunar to get there, you need a much bigger rocket. Obviously, Jack talked about the NASA's SLS, but I think it's going to be a combination of NASA's SLS and commercially available rockets. And several different companies are developing much bigger rockets to increase their launch capability and get us to that cislunar space.
Okay.
Yeah, Rick's absolutely correct.
Okay, so you're looking at a totally different class of launch vehicle to get these up where they need to go.
Absolutely.
What about, and this is also from Raj Luthra, and I'll ask you, John, about this. He goes, will there be any international space agencies involved in this effort? And I'm going to expand that not just for the Gateway habitat, but I'd like to know about getting us back to the moon. Are there going to be international agencies involved?
That's a great question. And with Gateway, we absolutely have international partners involved. They've been involved from the beginning of our formulation activities. We've got great relationships that we've built through the International Space Station activities and other activities as well. But ISS is a great analog for what we're trying to do. And we have ESA and JAXA and CSA all very much involved with what we're doing already. And as our administrator talked about last week, even at IAC, we're very open to international partnerships in putting the Gateway together and making sure that we have that cooperation to achieve what we're trying to achieve.
Are they involved? Are they involved now with some of these components? Because, like I said, you're building this stuff now, right now.
We are, and they are already involved. Absolutely.
Okay.
So you were talking a little bit about robotics, for example. The Canadian Space Agency is working on the Canadian arm for the Gateway, similar to what they did for the Space Shuttle and the International Space Station. So there's a lot of activity internationally that already is going on.
All right, let's talk a little bit about some of the advantages of doing it this way. There's as I have been following this program, there's been two big camps as I can see it. One of them is, well, actually there's three if you want to include the Mars guys. They just want to go straight to Mars and forget the moon. Let's not talk about that for a second. But of going to the moon, there's two big camps. One of them is let's just go there and land and build there on the moon. Let's forget about this Gateway thing. And then the other one is, which I'm actually in this camp. I think the Gateway is a good idea, and I think it's smart to build this way and then go to the moon. What are the big advantages, John, that NASA looked at when they decided to do it this way instead of just going straight to the moon?
So really the biggest area is sustainability. We're looking at creating a capability that allows us to continually be able to learn about cislunar space and be able to repeatedly access the surface as we choose to do so in a much more sustainable fashion. So the Gateway gives us that opportunity. There is, I understand, the other camp where you could go direct to the surface, and that's what the Apollo missions did, right? So obviously that is an approach that could be taken, but that's not doesn't provide you that sustainable infrastructure that allows you to do more long-term surface ops on the surface of the moon, nor does it really prepare you for how you would want to do your Mars exploration. You probably would want some type of architecture that has an outpost in Mars orbit as well in order to execute that type of capability.
And that's what I like about it too, is that it provides not only a smart way of getting to the moon, but also it's a test bed for what we're going to have to build and and understand about going to Mars. I think this is highly. I think it's highly suitable to do this in cislunar space because if you just go to Mars, if you just build stuff to go to Mars, I mean, we're going to test. Everybody tests. I get that, but it's hard to do it. We could do it on a much better job of testing these components in something like the Gateway to get us experience in handling what we're going to need to be able to do to get to Mars. Not the least of which is being out in space for a long time, which is something that we need. I don't know if any of you can talk about well, I know you can. I know you can, Rick. You could talk about the mental stresses that go on in being in space, and I'll ask you about that in just a minute. But we don't have a whole lot of experience in this area, and I think it's hugely important if something goes wrong to only be a few days away and be able to get back people safely. So from a safety perspective, this is absolutely worth doing. And then from a test bed perspective. So I think that's really important. But I would like to ask you, Rick, because I did get a question from Raj about this, about the mental health of the astronauts in long-term space. What experience can you share with us about what the mental workload is in being an astronaut on the space shuttle, and how do you think this will help prepare for going to long-term stay in space?
Right. Yeah. So my first missions were space shuttle missions, and those were 2 to 3 weeks long. My last mission about 5 years ago was a long duration mission where I launched on a Soyuz spacecraft and it lived on board the International Space Station for 6 months. So that's much more difficult. Going someplace for 2 or 3 weeks, that's like going on a vacation. But when you're living someplace for 6 months, you're right. There's a lot of different emotions and different feelings and different things that you're going through. Sometimes you feel like you're overwhelmed, and sometimes you feel like you're bored. So, and every individual is a little bit different. So there is a balance that has to be achieved in terms of giving the crew useful work to do. And that usually comes in the form of maintaining the spacecraft or the gateway or the space station, or in the terms of giving them science to perform to contribute to the mission. And that's really the trade-off: is give the crew enough work, but also give them enough free time to also, to not be overwhelmed. And the big difference, obviously, low Earth orbit. Whenever there was an emergency, the ultimate answer when you were in low Earth orbit is jump in your spacecraft and fly home. Jump in your Soyuz, jump in your space shuttle and fly home, and you're home within a few hours.
Right.
And that mentality is going to be very, very different when you're at the gateway in cislunar orbit, whereas you're going to jump in your spacecraft and it's going to take you up to 5 days to get home. And if you're in a vacuum, for example, you have to stay alive in your suit in a vacuum for 5 days or as much or more. So it's a very different vehicle that has to be designed. We have to design better safeguards, and we have to keep the crew healthy in a lot of different ways.
Yeah, that blows me away. I mean, just the idea of 5 days having to get back quickly is bad enough. I couldn't imagine the months of journey that it would take for Mars.
Many months.
I know. So do you ever think about that when you were up there in your 6 months in the ISS? Were you like thinking to yourself, boy, you could look out, there's the Earth, you can almost touch it. It's so close and just huge. It fills the viewports. But what if it's just a tiny distant speck? I mean, did you ever think about that when you were up there? What it would be like to be so far from Earth?
Yeah, it did a little bit, but it's risk versus reward. If you're looking out the window and the moon is out your window, you got this great reward of seeing the moon. But of course, the risk is that it takes you longer to get home. And then the same thing is if you're orbiting Mars, you have a bigger reward, but of course you take increased risk. So I think it's all worth it in the long run, but it's definitely a different mentality.
Yeah. So, John, give us a quick outline of what a typical mission, an Artemis mission, is going to be like, including the gateway. Can you just maybe outline what the trip will be like and how long it'll take?
Sure, absolutely. So we'd expect, as we talked earlier, right? You have the PPE and then the Halo module get up ahead of time before the crew would actually go. You'll also have your human landing system launched and in place at the gateway, as well as a logistics supply vehicle, all intended to be at the gateway before you would actually launch crew towards it. So So you get into 2024, you launch crew using the SLS launch vehicle and the Orion capsule. We get up to 4 crew would be on their way out to the gateway. That would take probably 7 days or so to get out there, 5 to 7 days to get out to NRHO, the orbit that we'll be in around the moon. And we go from that point, the Orion capsule will come in, it will dock, as you showed in the image earlier, it will dock on the end of the gateway, attached to the Halo module. And from there, we'll be able to have the crew open the hatches, enter the Halo module. They'll do prep work that they need to do, get whatever logistics supplies that they need to make sure are outfitted within the HLS, the lunar lander that they'll take. They'll do that prep work, make sure that they have their EVA suits, for example, their EMUs that are moved over. We expect 4 crew will go up. 2 of the crew will then enter the lander, and from Gateway, fly down to the lunar surface. One of the things I didn't mention earlier that Gateway does provides access to a lot of different areas of the moon. So we expect to explore the South Pole, for example. And so this lander will be able to then leave Gateway, land on the surface, be down there for about an orbit is what we're expecting. So that's an orbit for the Gateway around the moon takes 6 to 7 days. And so on the way back, then we'd have that crew would return back to the Gateway and then be able to, as Rick mentioned earlier, bring whatever moon rocks or things they collect from the lunar surface, bring them back into the Orion capsule and prepare for their return home. So overall, you're talking about approximately a 30-day mission.
That's amazing. So from launch from Earth to getting back to Earth, we're looking at about 30 days?
Correct.
Wow, that's amazing. Well, you mentioned the South Pole, and we're going there because it happens, I think, that we've been finding, and the Chandrayaan-2 mission that was just launched has an orbiter that's looking at that. They were going to have a lander, but it didn't make it. The story there is water, isn't it?
That's correct. Water and other volatiles. It's very important for us to determine what exists there and what we can use, what we can extract and be able to use to continue exploration on the lunar surface, as well as to advance capabilities that allow us to do things like extract water ice or create liquid oxygen as a propellant, things like that we could use as part of a Mars architecture again as we go forward.
And Stephen, so I'm trying. I was under the impression you were working on more habitat-oriented things as far as the design of it, but it turns out, if I understand you correctly, you're working on the software involved in getting these habitats operational, especially when they're empty. So, with what you know about the Lunar Gateway habitat, are there going to be periods where there's going to be emptiness there? It's going to be unmanned. And do you worry about the degradation of the systems once they're gone?
Working backwards through your questions, yes and yes.
Okay.
Of course we do. But let me expand a little bit about what we are working on.
Yeah, okay.
The NASA has invested in the future of habitat design in something they call a Space Technology Research Institute. There are 2 of them. One is led at UC Davis, one is led at Purdue. They're brand new. This started in October. And these are 5-year programs, research programs. They're pretty big. They're $15 million research programs. The one that I lead is called HOME, Habitats Optimized for Missions of Exploration. And our mottos are keep the vehicle alive when nobody's there, keep the crew alive when people are there. Now, this is a pretty large group. Again, NASA sponsored, NASA funded, and it's about half of the experts involved have space expertise and background, and the other half do not. The idea was to bring in some new ideas from civil engineering, the smart building world, industrial robotics, a lot of machine learning and AI applications that are further ahead than what we have done for spacecraft so far. So this is besides UC Davis, it's University of Colorado at Boulder.
Ah, my alma mater. Sorry.
It's a pretty good place.
Go Buffs.
Yep, exactly. Carnegie Mellon University, Georgia Tech, Howard University, Texas A&M, and USC. And so it's a big group of universities. So we're looking at this integration between the humans, the required robotics, design and repair on board, and the learning software that can be used to advance what both what the machine and the crew are capable of doing as the life of the vehicle progresses. We think it's exciting and complicated. We're not designing Gateway. We're using Gateway as a lesson plan for us to think about the correct context for these challenges.
And John, are you guys working on something like that for Gateway? Like, I'm sure you are. When it's not being inhabited or when it's not being crewed, you've got systems in place that are being designed now that will handle all this automatically.
That's absolutely correct. Yes, we're looking. You talked about that first mission. We mentioned it was 30 days long. Well, that's 11 months then in that year that it will be uncrewed, and so having autonomous capability built in is something that, yes, we're working very hard to develop right now to make sure that we have that capability on board when we launch.
And is it like what Stephen said, we're talking about making decisions here, decision-making software, right?
That's absolutely correct. To the extent, obviously, we can work with Stephen on what he's doing, and the research. There's a lot of different research areas that I'm sure can be addressed with autonomous software development. We're looking to make sure that specifically the capabilities that we need to bring up within the Halo module, as well as the PPE, so that those we can make decisions on, whether they're real-time, immediate decision-making is needed, or that provides for some more long-term management. We're looking at all of those capabilities to build into the software.
Okay.
One way to think about this, there's a lot of ways to look at it. One way to think about it, the way that the NASA Space Technology Research Institutes have been set up, is that there is the vehicle should have self-awareness. In other words, it should have a sensor suite and software to be able to know what its state is, and the state estimation of what diagnosis of its health and projecting prognostics for the vehicle health are all about. But then you have to have take actions. So once you have an awareness, you have to take some actions. But as John said, in between, and you said too, Tony, the decision-making process is kind of the key. And that probably is not going to be entirely autonomous. It will be different when crews on board. There's always going to be people on the ground, but they may be pretty far away in terms of time. So how we optimize those kind of integrations and interactions between the software, the hardware, and the crew, that's what the research is.
Okay. And are you guys so Rick, when you guys are working on this stuff, you guys are also incorporating this kinds of thinking into the habitat module, right?
There's certainly requirements for it, and yes, that's in the process of being developed.
Okay. Do you are you gonna have like 3D printers on this thing, or is that going to be another module for something later? Right now, you're just focusing on the habitation part of it. I mean, is there anything that's going to be built into this thing for longer term maintenance?
I think right now, and John can correct me, but I think right now we're trying to get the basic minimal habitat up there so the crew can do short duration missions. But yeah, there's nothing to preclude us from adding 3D printers or other maintenance type hardware in the future.
Okay, and so also, Rick, what lessons have you learned from the ISS experience, from both living, sleeping, cooking, going to the restroom, all of that, that you're going to maybe either incorporate into this new habitat or maybe hopefully improve on, make it a little bit better?
Yeah, so you have to be careful in my mind, and then maybe this is more an opinion than a fact, but
we love opinions.
International Space Station is a permanent living module. In other words, the crew members are living there for long periods of time. So you need a certain level of comfort, if you will. Whereas on space shuttle missions, for example, you went up, and Steve Robinson could talk about this also, you went up for 2 weeks, 2.5, 3 weeks, and you had a lower level of comfort. You didn't have any privacy. You didn't have your own crew quarters. Whereas when you're living up on the station for 6 months, you have your own crew quarters, for example, and it's basically a phone booth. So you get a few minutes of privacy when you have to sleep and things. So the gateway, at least in the early days of the gateway, is going to be somewhere in between there. So do you make it this more comfortable module where each crew member gets his own private space, or do you make it more like a space shuttle mission where it's a short duration and the crew roughs it? It's more like camping rather than living. So I think it's a trade-off. And I think in the early days of Habitat, you could put too many requirements on the gateway, and you're going to drive up the cost and the size and things like
and
that.
The time of the
right,
day,
and the time. So I think we the community, NASA, the contractors all need to be careful not to make this thing too complicated. I think the goal is to keep it simple. Maybe the crew has to rough it out for at least the first few years until we start adding additional capability to it.
John, when are you looking to make a decision on this? On who's going to build it? Maybe not you personally, but NASA is a
right.
whole.
So we've talked about the pieces that are already in work. So the Maxar Technologies is already on contract to build the power and propulsion element for Gateway, and the Halo module, Northrop Grumman is already on contract to build that. Though we're negotiating the final contract right now. But so that those decisions have been made. There are still future decisions to be made relative to the human landing system and the gateway logistics services and things of that nature as we go forward. But these early pieces, decisions have already been made, and we're moving out to make sure the requirements are understood. And Rick went through it very well in making sure that we're building what we need to accomplish the 2024 mission and allow for extensibility in the future if we want to bring up additional capabilities as we move forward.
If the oh man, my question just went away. All right. Well, let me just ask. I hate when that happens. Let me just ask a question from a viewer that I had. I wrote it down because he wrote it down before the hangout started. This is from Ron Belts, and he goes, this is an opinion, I think, from all of you. So you can give me your opinion. Which will become sustainable and healthy for dwelling on the moon? Should we build on the surface or in the subsurface? And I think he means for a longer term stay. What are your thoughts on that? I mean, I know we're a bit away from that yet, but for a long-term presence on the moon, is it safer to build a habitat on the surface or to go underground? And I'll start with you, John.
Okay, and so I think it's a good question. Obviously, there are still trades to be done. I've seen people looking at design concepts where you go underground, you go into lava tubes, and there's I think Stephen was talking earlier about radiation protection. There's different advantages that you can get out of that. There are though disadvantages that go with actually doing the development work in that environment versus being able to bring a habitat that you could just position on the surface. So there's clearly trades that need to be made, and I'm not sure that I can answer the which one would be safer perspective because there are so many different aspects that go into safety. I think that's what would have to be looked at, and there are actually teams looking at what surface capabilities should look like and how we should go about executing those missions, because that is where we want to go with the whole extensibility with this Artemis program.
What do you think, Rick?
Yeah, I think John said it pretty well. I think in the early stages, you're going to be living on the surface in habitats that are dropped off. And eventually, as you build the infrastructure, I think you could then maybe dig into the sides of hills and try to use the moon itself to get protection from the radiation. But again, it's a trade-off. I think long-term, probably underground is safer because anytime you put material between you and radiation, it helps you.
Right.
But the short term is just drop off a habitat and then minimize the time on the surface for each crew member.
Stephen, you got any thoughts on this?
Well, I agree with my colleagues. If you've ever seen a building, let's say the basement for a building, which is often how a big building starts. You ever look at the amount of equipment it takes to dig out that basement right here on Earth? Imagine that on the moon. Now, of course, it's 1/6 gravity, but That's going to be a tough problem because that's a lot of machinery to get up there, probably much more than habitat itself.
Yeah, it's a lot of
So-
moon movers.
Yeah, a lot of moon movers. So I'd rather be underground for radiation protection, but I don't think we're going to be there for the near term.
Yeah, but I think of it as a quality of life issue too. If you're talking about living somewhere, then living in a hole in the ground is probably not going to be the best quality of life that you're going to experience there. And we're talking living and colonizing. I think we're gonna be looking at doing it on the surface in some way. Although that is, as we all know, quite dangerous. But
Radiation could affect your quality of life.
well, yeah, it does. It does do that too. I'm not denying it. But I'm just saying that living in a hole in the ground and getting. I mean, it's the whole thing is overwhelming to think about. And so
there's another aspect too that we haven't. I'm really glad John brought up, and you did too, the ISRU opportunities. In the '60s, I don't think we had any concept that there was potential usable.
ISRU is in situ resource utilization, using stuff you have on the moon. That's what that means. Go ahead.
Yeah.
Sorry.
And water being potentially one of the main ones. But there's bad stuff too. The moon is a dusty environment, and the dust is horrible. It's the worst kind of dust you could imagine. And so if you have any kind of seals, which of course you need, any kind of rotating machinery, any kind of thing where friction's gonna play a role, you've got to worry about this kind of thing. We don't have much experience in that kind of thing, at least off the surface of the moon.
Yeah, that's right. And so we're not going to solve that particular issue right now, Ron, but at least we have our opinions on it. So I remember what my question was, John. I wanted to ask you about the SLS. How's it going? And just give us a general overview of the SLS. And I think the last news thing I heard was that the main rocket thruster thing is being moved to Stennis. Is that right?
Right. So they're getting ready to do what's called a green run test, where they can run through and demonstrate that the SLS design will work as they intend in an integrated fashion before they actually go put the first vehicle together to launch crew. And so that work is ongoing. I think that's in the near term. I can't remember the schedule off the top of my head, but it's pretty soon that they'll get out there for the green run test, and then build the components they need to get the Artemis 2 mission out and executed.
And Artemis 2, that's the one that's unmanned. That's the flight. You tell me, what is Artemis 2? What's that mission going to do?
Yeah. So Artemis 2 will have the SLS and with an Orion capsule on board. That Orion capsule will execute a mission. I think it's about 3 weeks long. Go around the moon before returning and re-entering the Earth's atmosphere. It is uncrewed, as you said, but really demonstrates a lot of the capabilities that are needed within the Orion capsule, and demonstrates the SLS launch capability itself before you put crew on with the Artemis 3 mission that we're looking at in 2024.
And Artemis 3 is going to be that, like you said, it's landing on the moon, right? Without people. And then Artemis 4 is the biggie, where we put people on the moon.
So no, Artemis 3 is actually the one where we send people to.
Oh, it's 3. I'm sorry. I thought
that's correct.
Yes. My mistake. Okay, great. Even better. Sooner it gets out there. John, I don't want to get personal here, but I think you're younger than me, and maybe you don't know the answer to this question. But how does this compare in your mind? What are you guys saying about at NASA about how this compares with Apollo? This is a big deal. We've been there before, but what's the feeling at NASA about Artemis as maybe compared to Apollo? I don't know if that makes any sense, but
it does, and actually get the question a fair bit. It actually there's a tremendous feeling, and I think it's not just at NASA; it's across the industry of where we're headed, and a sense of urgency in order to try to get these missions off and return to the moon. It's been a topic of discussion, as you know, for many years. Even we're very proud of the history with Apollo, the work that was done, the things that people did to actually execute the full suite of Apollo missions was fabulous. And I think we always need to retain that understanding of how they were able to accomplish those missions, the risks that they took, how they took risks, and how they adjudicated risks. I think those are all important lessons for us. But as we go now with this with the Artemis program, The idea is to not just do the same thing that we did with Apollo. As great a mission as it was, we really want to focus on, like I was talking earlier, the sustainability, the opportunity to actually be able to stay out in cislunar space and do much better development of the resources that exist out there that really enable us to not only explore the moon itself and create maybe even business cases and opportunities in the lunar vicinity, but then allow us to go out into further, deeper space, explore Mars, and go even beyond.
That's a great point, because while we have gone to the moon before, and we have, Apollo got us there, we had to invent a lot of technologies to get us to the moon for the first time. Other than going to the moon, there's not a whole lot that this has in common, Artemis, with Apollo as far as the technology and the way we're going to get there, because Apollo was a lot of things, but sustainable it wasn't. So, and with this in mind, with the sustainability first and foremost, and this long-term vision of going and staying on the moon, a lot of technologies, I would imagine, don't overlap. You can't really build on that experience other than what you just said, how you take risks, how you manage these risks. That was probably an invaluable experience, and I'm sure it also comes in handy with the ISS experience as well. So, I don't know. This is kind of interesting. Is that Northrop Grumman? It wasn't Northrop Grumman in the 60s, Rick. It was Northrop, and then there was Grumman. And I forgot what they built. I don't know if it was the lunar lander.
Lunar lander.
Was it the LEM?
Yep.
Okay, yeah. So they've got experience, obviously, with getting to the moon. What can you tell us about the atmosphere at NG? I'm pretty sure you probably weren't on the Apollo mission, but you can't use direct experience. But do you know what I'm asking? Like, are you guys jazzed up in a way that might have been similar to what happened back in the 60s?
Yeah, I think John said it very well. I think it's not just the NASA folks who are excited, but it's the various commercial providers are also excited. There's a lot of things going on. NASA is really pushing the envelope. It's asking a lot from the commercial companies like Northrop Grumman and all the others. Is asking us to provide a lot of hardware, asking us to to be innovative, figure out all this new hardware, these new trajectories. It's a different orbit. It's a different way to get onto the moon. It's sustainable. So it's completely different than Apollo. I mean, it accomplishes the same thing in that we get folks on the lunar surface, but it's much more than that. So it's a very exciting time.
Yeah.
I left NASA about 2 years ago. And before that, I was working on the Orion program off and on for 10 years. While I was off flying my various missions. So I got that I got that lunar bug bite when I was at NASA, and now I'm continuing in my career here at Northrop Grumman. So it's an exciting time for everybody. It's going to be very, very challenging, but that's what makes it exciting.
Well, I got a quick question, but that only you can answer then, because you've worked on Orion and you were a space shuttle astronaut. How do the spacecraft compare in terms of technology and just general overall space worthiness? I mean, the space shuttle was built in the late 70s and the 80s and had technology that reflected that. Now Orion is state of the art. How would you compare based on your experience between Orion and the space shuttle?
There's a couple of big differences in my mind. First of all, the space shuttle, imagine if you will, when you're sitting in the cockpit of the space shuttle, you're surrounded by, I think it's something like nearly 2,000 different switches and dials and knobs and buttons and gauges. And as a crew member, as Steve can tell you, you need to know what every one of those switches does. There's 2,000 switches, and everyone does something different. You have to know. Orion, and I was part of the cockpit development team for Orion, is very different in that it's all glass cockpit, and you have maybe you have 20 or 30 switches for emergency backup functions. But everything it's really a glass cockpit, very much software driven, saves a lot of weight on all these different switches. That's one of the big differences. The second difference is the space shuttle was a highly redundant vehicle. It had pretty much three of everything. It was called fail ops, fail safe. On the space shuttle, if you failed one guidance system, IMU, for example, you were still operational. You could still continue with two others. And if you failed the second one, you were failed safe. In other words, you could fly home and return home safely. Orion's a little less redundant, but it's relying on a more reliable hardware and less redundancy. So it's the quality of the components has increased to a point where we can have less of that. But it's also a very different mission. So there's a lot of differences in the vehicles.
Okay. Tony,
go ahead,
I can
Steven.
weigh in on that on the outside.
Okay.
coming from an aero background. I started working for NASA in 1974, so in between Apollo and Shuttle. And so I was working on the kind of the final design parts of the shuttle, mostly for the entry, the heat shield design. Anyway, Orion is a capsule, and a capsule coming down through the air is a vastly simpler aerodynamic problem, both in terms of guidance, navigation, and control, and heat rejection for the heat of entry. Simple is really good when you come. Now, deciding exactly where you're going to land, you don't get that position with Orion.
No, that's true.
The space shuttle was a technical miracle, really, in terms of aerodynamics, high-speed aerodynamics. Flying at very high Mach numbers where nobody had ever flown with a lifting vehicle before. It was just incredibly complex, and as you know, it didn't always work.
Yeah,
there were failures that we had that were our own fault, but it was a very complex vehicle aerodynamically. So the capsules are much simpler. They're not always better. There's times, like we're designing right now a space ambulance for ISS as a concept. And if you have a severely injured crew member, you need to get them back to medical care at a specific location. A capsule probably wouldn't be appropriate for them. So there are trade-offs.
And if I recall, the flying body design of the space shuttle, Rick, you can correct me if I'm wrong, but I've heard it described as sort of a controlled free fall, where you're gliding down and you're going down at a pretty high rate of descent. You do have control, obviously, but it was a pretty steep glide path. Is that right?
Well, not as steep as a capsule.
Yeah, which is right. But I'm talking about controlled. I'm talking about controlled flight and return. I get that.
Yeah. The shuttle was a big glider with about a 4-to-1 glide ratio.
Right.
The capsule has about 1.1 glide ratio. So
I returned from orbit in both the space shuttle and a Soyuz capsule, and I could tell you that the space shuttle was a lot more comfortable.
And probably a little more comforting as far as
and you landed exactly where you intended.
Yeah.
Exactly.
And the Soyuz capsule, the analogy I use is you're like a shoe in a dryer.
What's it like when you hit? I mean, is it because they do land recovery? They don't splash down. What?
Yeah, they have soft firing engines. The Soyuz does just before you land, and they're not as soft as the name implies.
I can imagine. Wow, that must be terrifying to see the ground coming up at you, and you're just like, "Oh, I hope these things fire." All right. Well, I guess we will. We're almost out of time, but I just want to get one more question in for John from Hans Milling, because I want to know this too. In 2024, when we get these people on the moon, walking around, doing great things, are they going to be able to stream in 4K? And so we can see what's going on. What's the internet? What's the bandwidth going to be like on the gateway? Are we going to have like some pretty high speed internet there?
That's a great question. And actually, we are trying to make sure we set up the requirements and get the capabilities in place to have good high definition video for the mission. Like we've been saying, we're real early in the development, but that's what we're shooting for, and hopefully we'll be able to produce that for the mission.
Well, unrelated question: what type of this is from Raj Luthra? What type of communication system is going to be on the gateway? How are we going to communicate back and forth? And I'll expand that to say, are you going to be using TDRS, or is it just going to be its own communication system?
So we'll have a variety of communication systems, actually, because we need to be able to communicate with Earth. We need to be able to communicate with the lunar surface. We have to communicate with every visiting vehicle that comes up in order to be able to dock each one together. So there's actually a variety of communication systems. We will use the Deep Space Network and the networks that exist in order to do a lot of the communication with Earth. But we'll tie all of those comm systems together to be able to make sure there's, number one, no interference, and number two, that we can get all the communication that we need from all the different assets that we have to coordinate.
Okay, and one final question for you, Stephen. I'm a software engineer. I spent my entire time writing computer software. Any Python going to be on all these spacecraft that we're talking about? These AI and deciding pieces of software. I love Python.
Yeah, probably.
why-
That's what a lot of engineering students are now turning to.
It's the language, folks. Okay, it's not a real-time programming language, but it is. If you want to become a software engineer and work in space, you need to learn Python.
No, you don't.
Yes, you do. Yes, you do.
Let me actually just kind of sign off with one very encouraging thing. Right now, if you're thinking about being a student of aerospace engineering, going into school to study that, or going into graduate school and thinking about the future of spaceflight, especially human spaceflight, there has never been a better time. Look at all the different vehicles that are being designed by different companies with different engineering philosophies, but all tied together with a combined shared mission across the world, really. And all the different rockets that are being designed. I mean, look, we've got LOX methane rockets coming out of 2 companies right now that are very large, never been true. Different launchers, deep space launchers, light launchers, launchers for CubeSats. Going back to the moon, we're talking about lander. There's such a variety of things. There's never been a better time to jump into aerospace engineering.
I couldn't agree more.
That's my pitch.
That is a great way to end this. As a software engineer who's worked in astronautics and aeronautics for my entire career, I can tell you, if you can program things, if you can build things, if you can design things, if you can process data, you will get a job in astronomy and astronautics, because they are in high demand, and it is a great skill set to have. And you don't necessarily need a PhD to get a really rewarding career in these fields, because I'm a testament to that too. I've got a bachelor's from CU in physics, and that was all I needed with my software background. So be encouraged. This is a golden age. If you can program, design, build, and process, you are golden. So I couldn't agree with Steve more. Okay, guys, we're going to have to cut it there. I promise you I'd hard cut off at 4 o'clock. I want to thank my guest, John Olenson. He is the Gateway Production Manager at NASA's Johnson Space Flight Center. Rick Mastracchio, he is the Program Manager at Northrop Grumman, working on the Lunar Gateway habitat for Northrop, as well as he's on the Cygnus spacecraft group as well. He's right now in Virginia, going to go supplying the ISS this Saturday. So thank you for taking time out, Rick. And Stephen Robson, he's a professor at UC Davis and the director of the UC Davis Center for Spaceflight Research. So thank you all so much for taking time out to watch us. Next week, we will be back, next month, the American Astronautical Society Future in Space Hangout will be back toward the end of the month. I'll send out notifications when that's going to happen. So stay tuned. All right. And thank you all so much.
Thank you, Tony.
You're welcome.
Thanks, Tony.
Yes.
Good job, Don.
All right. Thanks, guys. Thank you so much. On behalf of all my guests, thank you all so much for watching. And as always, keep looking up. Okay. You just turn off the streams and we are done.